Hey guys, Eid Mubarak from me, and today I have came here with a new interesting problem, solve Eid special ED program using greedy algorithm. So let's have a look to this problem statement. Okay, it is a Eid special DSA problem, ED distribution. So what it states, let's check out the problem statement. The problem statement states that on Eid you want to distribute ED money to n children standing in a lines. ED means the gift or a price of money which is given to the children as a salami. We can say that. Okay, the parents, the elder person gives to the younger children, and after salami as an ED, some sorts of money as a presents. Okay, so we have to distribute n children to this ED money. Okay, that's fine. Each child has a happiness rating given in an array, that is ratings. Okay, after taking money, the child will rate their happiness in an array which name as ratings. That's fine. There is certain rules. Number one, every child must get at least 1 unit of ED. Okay, we have to distribute 1 unit of ED for n number of children. That's fine. Second rule is a child with a higher rating than an adjacent child must get more ED than that neighbor. Okay, suppose if let's say we're gonna take 3 children. Okay, so the first one rating is 1, second one rating is 2, then third one rating is 3. So the third child must get the amount of ED more than child number 1 and child number 2. So we have to make such an algorithm. Our task is to return the minimum total ED required. Okay, we will take an input rating equals to the rating must be stored in an array. So we're gonna use as stated a greedy algorithm because it follows a greedy approach. So let's implement the code in our code editor. Let's create a new Python file with the name ed.py. Great. So first we have to take the input from the user, the number of children. So first variable we are taking the input. Input, what we're gonna write, enter the number of child. Enter the number of child. Fine. So next what we're gonna take the input of rating from each children. Okay, so based on the rating of the children we will assign the ED. So for that let's create a rating variable which will store the rating in forms of list. So it will store the value in list, and I'm using the map function as it is very fast. It will store integer value and it will take input from keyboard. So we're gonna first display a message that please enter the ratings separated by space, or else we won't be able to recognize it. Okay, next we're gonna use the split function. Fine. So whenever there is a space between two value, it will split that value, and it will append that to the list as a new element in the list. Okay, so very first we need to create our function, that is def ed. Okay, and for that function we need to pass our parameter, that is rating, because on the basis of these ratings only we will design our whole algorithm. And very first work is to calculate the length of our rating in array, that is rating length. Fine. Now if we look to the question back, the very first rule expresses that every children must get at least 1 unit of ED. So for every children starting from 1 to n, they must satisfy that each children might get at least one ED, at least 1 unit of ED. So for that, what we're gonna do, that mean ED. Okay, I'm taking mean ED. So we're gonna assign 1. Okay, we're gonna assign 1 for n number of children. So I'm writing it in commenting out, everyone gets at least 1 unit of ED. Fine. So our next step is to, what we're gonna do, our next step, if we look back to the question, a child with higher rating than an adjacent child must get more ED than the neighbor. Okay, so what's actually means, it actually means that if we iterate from left to right, and if right is greater than left, or left is if right is greater than left and that the adjacent is greater than left, then we need to assign a greater value for that higher rating. Okay, on the base of the rating, if the rating of the adjacent, that is right, is greater than the rating of the left, we need to assign the higher value for that particular index, for that particular child. So for that we're gonna use the branching concept, that is for loop I in range, it will start from 1 and go to till up to n, that is length of the ratings. So if we need to check the condition, if ratings of I, that is index I, whether greater than ratings of I minus 1, if it's satisfied, that what we're gonna do, we're gonna perform mean ed, that is mean ed, mean ed of I equals to, we're gonna assign the higher value to that, that is mean ed of I minus 1 plus 1. Great, that is sorted. Moving from left to right, I am commenting out moving from left to right. Fine. Next, what we gonna do, we're gonna for our back, that is if it is the condition for if left is greater than right. So for reverse order, we have to also check that whether the right is greater than left. So similarly, we are taking another branching concept for I in range 1 to, sorry, it will start from reverse order. No, so the reverse order will go from L minus 2 and it will iterate by minus 1, will iterate by minus 1 up to minus 1 index, that is up to last index. Fine. So now we're gonna check if rating of I, sorry, if rating, yes, if rating of I, whether it is greater than ratings of I plus 1, of rating of I plus 1, then what we're gonna do for mean of ed I, okay, what we're gonna do, we're gonna assign the, we're gonna find the max, which index is max. So for that, I'm using the max function of ith, whether it is ith I, or that is, or the max is if I plus 1, whether it is I or I plus 1. If it is I plus 1, then we will increment 1, then we will increment 1 to it. Fine. So for this, it was checking from left to right, and in this condition it will check from right to left in reverse order, whether right is greater than, whether right is greater than left or not. Okay, and it will return, the whole function will return a value, that is return, what it will return, it will return sum, total sum of mean ed, that is total sum of minimum ed, that is what is the minimum ed. It will, we need to find that only, no, in our question we need to find that only. So it will return this value. Okay, it will return this value. So let's call the function. So if length of ratings, if length of rating not equal to n, that is we need to check whether the length of rating is n or not, because for n number of children we need to take n number of rating, no, or else we cannot take the rating number greater than n. It is not possible, because if we take the input of 3 children and we take the input of rating for 4 children, it will mismatch, totally mismatch, and there will be an error encountering. So for that we need to cross check it. So we will print an error, please input valid rating for valid number of child, else we will return, else we will call our function, that is result equals to mean ed, sorry, result equal to our function name was ed. Okay, it will pass the argument, that is ratings. Okay, ratings, and we will print the message that minimum ed required, is required, that is we will approach the result, that is our result value. So let's run the code. This is our very little code, and let's check it whether it is. So for 3 children I'm taking the input of 4. Okay, for 4 children let's give the rating, that is let's check the rating whether it is coming correct or not. For first child the rating is 1, for second child the rating is also 2, for third child the rating is 2, and for fourth child the rating is 3. So let's check the rating. Okay, let's check whether if rating, let's check where it is error, length, okay, sorry, here it is missing just one braces, one closing braces. Fine. So now let's rerun this. So I'm taking the number of children as 4, and the first child gives the rating suppose as 1, the second child rating gives 2, this third child gives also rating 2, and fourth child gives the rating 3. So if we just calculate, we can see that the first child gives rating 1. So for each child, the first ED will be assigned, that is 1. And for second child, the rating is 2. So that is the adjacent is greater than 1. So for it was already 1. No, so it was 1, and for as it is greater than the left, so the value becomes 2. And the if we move to the third child, the rating of it gives the rating of 2, which is same as the rating of left, so there will be no increment. So it will assign only 1 unit of ed. And if we check the fourth children, the rating is higher than the left, the right rating is higher than the left, the adjacent is higher than the left, so it will obviously receive a increment unit of ed. So there the total number of ed must be 1, okay, 1 2 1 and 2, that is 1 plus 2, that is 3, 3 plus 1 4, and 4 plus 2, that is 6. It must give 6. So let's check it. Yes, the code is running correct, so it is giving 6. So let's check with another input. For 3 children, if we assign the value, that is the first children gives the rating 2, the second children gives the rating 1, and the third children gives the rating 3. So let's check what is the ed. The minimum ed required is 5. Why it is 5? Let's cross check it. If the rating of adjacent is greater than the rating of the adjacent one, so the increment, there will be must incrementation of the ed, because at least for each children they will first receive 1 unit of ed. Whether they give rating or not, that is not the fact. We need to assign 1 ed for each children. Okay, after that, if the rating is greater than the adjacent, we need to increment the value by 1. So check whether it is correct or not. That is 2 is greater than 1, so first it will increment, that is the first ed value is 2. For second, the ed value is 1. Okay, it is not greater, so 2 plus 1, that is 3. And for third child, it gives higher rating, so it will receive 2, because as it was has earlier 1 unit of ed, and second it will receive a 1 increment ed because it is greater than the adjacent. So the total number of ed becomes, minimum total number of ed required becomes 2 plus 1 plus 2, that is 5. That's great. So guys, if you like this video, please don't forget to hit the bell icon and subscribe to my channels. Bye bye. Keep coding and keep grinding, keep smiling, and stay tuned.